And we're back. Let's take a look at lesson 2.9 on reciprocating functions. This is example 2, for which there's a quick graph on the bottom of the lesson, but not really a process. We are asked to take a look at what the reciprocal of this linear function looks like. I've decided to add in the direction sketch R and state its domain and range. So trying this out purely algebraically isn't going to work out as nice as the last example. If I wrote out R of x's equation, it would be the reciprocal of negative 1/3 x minus 2. Now, I can try to manipulate this expression algebraically and get it to be a transformation of the parent reciprocal. This is not shifted right 2 because my k value hasn't been factored out. There's other problems that happen here when we start dealing with reciprocals of nonlinear functions and advanced functions. So what I'm going to do instead is take a graphical approach. And while normally a sketch will give us the level of accuracy that we need, I think for today to try to point out exactly what's happening when we reciprocate, I'm gonna switch to a graphing approach. So let me just get a piece of graph paper under here. And I'm going to graph the original. I'm going to be doing this with a relatively high level of accuracy. And then I'll show you how I can graph the reciprocal. So, sorry, trying to look for the original function. The original function is f of x equals negative 1/3 x minus 2. Let's get that up top. Boom. Let's make sure that we are strong with graphing linear functions. It's a little concerning sometimes. We spend a long time practicing quadratics and transformations of radicals, and then a couple of students just kind of lose track of how to sketch a linear function. Let's treat this like a grade 9 student would, as a function that has a dependent intercept of -2 and a slope of negative 1/3. So I'll go down 1 over 3, down 1 over 3. Down 1 over 3. Since I'm looking for a high level of precision, then I'll fill in more of these values over here. Whoops, up 1 over 3, like that. Not the best example at this scale, but we'll deal with it. Let's make sure we label this, because this isn't my final answer. This is the original function f. And what I want to do is come up with the set of ordered pairs that would belong to the reciprocal. Now, reciprocating is something that students often make more difficult than it has to be, and I've seen lessons that make this more complicated as well. What reciprocating does is very simple. It then just can cause some complicated graphs. You are taking x comma y and mapping it to x comma the reciprocal of y as long as y isn't 0. This is the same restriction that we saw at the start of Unit 1, that we cannot divide by 0. This means that nothing much happens to my x values as long as it's not a root. All I need to do is estimate or read off some y values and reciprocate them. So let's do that. Here's a y value of 1. The reciprocal of 1 is 1. So I put that point. That point is going to end up at, I'm kind of lost track of what the x value is. Let's call this whatever. It's whatever to the left, comma, up 1. Here's a height of 0. I can't reciprocate 0. Here's a height of -1. The reciprocal of -1 is -1. The reciprocal of -2 is -1/2. The reciprocal of -3 is -1/3. Reciprocal of -4 is -1/4. I think some of the problems that students have with reciprocating relates to an issue that they have with fractions. They think of the number -1/2 as an operation instead of as a number itself. This should feel familiar as well. It should feel like we're doing our parent reciprocal. And like when sketching our parent reciprocal, we notice that we're missing an awful lot of information in here. So what I'm going to do is just try to estimate some heights and reciprocate those heights. I know that somewhere between 0 and -1 will be a height of -1/2. the reciprocal of negative 1/2 is going to be negative 2. So where my original function had a height of negative 1/2, the image of that point across the reciprocal will be at a height of negative 2. I could eyeball and estimate where my height is negative 1/4 and try to reciprocate that to negative 4. If I was clever, I would use the fact that I know, because my slope is negative 1/3, I know that that height right there is actually exactly negative 1/3, and the reciprocal of negative 1/3 is negative 3. I should then be able to figure out that this height is exactly negative 2/3, and the reciprocal of negative 2/3 is going to be negative 3/2. Negative 1/2, 2/2, negative 3/2. I'm not going to be too picky about that precision, but any level of precision that you can do here is going to help you. I suppose I should be able to figure out that that height right there, halfway between that mark and that mark, is going to be negative 1/6. And the reciprocal of negative 1/6 is going to be negative 1, 2, 3, 4, 5, 6 right there. The reason why I can't reciprocate the fact that I can't reciprocate 0 results in this vertical asymptote. I'll draw a nice smooth curve best as I can through here. I have had assessments in the past where students were given a grid and they were asked to draw the reciprocal. It's also a very important topic for advanced functions. You'll see here why I said this wasn't maybe the best example, because I don't have a ton of room for nice points off in this direction, but I'll do what I can. There was the 1. Let's estimate where the 1/2 is going to be. Reciprocates to 2. 1/3 reciprocates to 3. 1, 2, 3. 2/3 reciprocates to 3/2. 1, 2, 3, 3/2. This is all you have to do. You just take y values and you reciprocate them. 1, 6, 1, 2, 3, 4, 5, 6. There's common questions include, how do you know what the curve is going to look like? Well, maybe I do, but I don't have to know what the reciprocal is going to look like. I can figure that out by just plotting these points on there. Let me label probably both of the arms. I think I mentioned that we were looking for the domain and range. Let's label our asymptotes on here. We've got a vertical asymptote at x equals negative 1, 2, 3, 4, 5, 6, which I think we could have figured out by finding the root of the original function. Anyways, there's my vertical asymptote labeled. Not all reciprocal functions have a horizontal asymptote of y equals 0. Most of the ones that you see in this course will. This happens when your original function gets really far from the x-axis in either the positive or negative direction, and most of our curves will do that. So there's my horizontal asymptote labeled. Domain and range then for R, for the red curve. Maybe I'll do it in red. It's a set of all x values. It goes left forever, it goes right forever, but x cannot be negative 6. Range. The outputs go up forever, they go down forever, but they will never be 0. There you go.